Hello friends, this video on alcohol, phenol and ether part 13 is brought to you by examfear.com. No more fear from exam. See, alcohols are very versatile compounds. They act both as nucleophiles and electrophiles. So electrophiles are not the alcohols but the protonated alcohols. So when it acts as nucleophile, then OH bond breaks. When it acts as electrophile, the CO bond breaks. We'll explain these things in detail. So this is my alcohol. When this bond breaks, OH bond breaks. This is my nucleophile. It acts as nucleophile. When this bond breaks, it acts as electrophile. Right? So depending on whether it is acting as electrophile or nucleophile, various bond breaks. Please note, when it acts as electrophile, it is protonated alcohol, not the normal alcohol. I'll reiterate this. When it acts as electrophile, it is protonated alcohol. We'll see these reactions now. So let's see what happens when it acts as nucleophile. What happens in this scenario? So in this case, as I told, my ROH I have this OH bond breaks. Correct? Let's see the reaction mechanism. I have R, I have O, I have H. Oxygen has lone pair. That means it has capacity to give electrons. It's electron donor, right? That means it is a nucleophile. It's a nucleus loving. And let's suppose there's a compound which has anything attached here. So it has slightly positive charge, let's suppose, because of some X or something, right? So this oxygen will give its electron to this carbon. So what will happen here is, what you form is C, right? And here you form O, let's suppose X is here, O, H and R. Right? Since this oxygen is giving electron, it becomes slightly positive charge. Now what happens is, with this hydrogen bond breaks and this hydrogen comes out. Because it's the OH here, and an oxygen, if it gets a positive charge, the hydrogen bond breaks, it becomes a good living group, and H plus comes out just to make the system more stable. So what you get is X or something like this, plus H plus is out. So here you see this bond is something which is broken. Let me put H here. Yeah, this bond is something which is broken. OH bond is broken. Correct. If you want more examples, you can take, I have ROH, react with sodium, I get RONA and hydrogen gas. Correct. Or I have ROH and this reacts with the B minus. What you get is BH and RO minus. So if you see in these cases, this OH bond is broken. Correct. Now we'll see cases where alcohol acts as electrophile. Please note here, this is not alcohol, but it is protonated alcohol which acts as electrophile. Please note, it is not alcohol, but protonated alcohol which acts as electrophile. So in this case, my ROH, right, this bond breaks, CO bonds. Example, I'll show you. My RCH2OH is my alcohol. This is lone pair of electrons. I get H plus. Now this will give electrons to H. So here it is behaving as electrophile, nucleophile only, because it is loving nucleus, right? It is electron donor. So it is behaving as nucleophile only here. But now once you protonate it, this becomes RCH2OHH, and since oxygen has given electron, it gets positive charge. Hydrogen gets a negative charge, negative and positive neutralized, so this is all neutral. This is what it becomes. Now OH2 is a good living group. Now in this case, if you see, this behave as electrophile. This behave as electrophile. So if you see, it is not the alcohol which is behaving as electrophile, It is the protonated alcohol. Please note, it is the protonated alcohol that behaves as electrophile. Correct? And it has got a positive charge. Now if you see, if I have any Br minus, let's suppose coming into play here, RCS2 OH HH, something like this, right? So this Br minus can easily attack this and this bond will break. So you get Br CH2R. There's a leave actually. So here if you see now here, this bond is breaking. This bond is breaking. This bond will break here. Correct? Since it was protonated, in fact this H2O is a good leaving group. It leaves. Right? The moment Br minus comes, this bond breaks here. Correct? So if I have ROH, you react with HX, you get RX plus H2O. Here also if you see, this bond breaks. Or here also if you see dehydration, also you see this reaction, you have OH, you have H, in presence of H plus, and you give some heat. So what you get is alkene, right? So here also you see this bond break, CO bond bro. So the way it works, you must have seen the mechanism. H plus attacks here, and this comes out, it becomes H plus, right? C plus, and then what happens is, since it's C plus, this H also comes out and it gives a double bond here. So we have scenarios where CO bond breaks and we have scenarios where OH bond broke. We'll take and understand these things in details now. So as we have seen that there are reactions which involves OH bond cleavage. This bond cleavage, right, where my alcohol acts as nucleophile. So where we'll talk about reaction with metals, acidity of alcohols, we'll talk about esterification, Grignard regions, acetylation, and there are scenarios where CO bond broke, right? So there we'll talk, and where it acts as electrophile, actually it is protonated alcohol. So in this case you will see most of the cases will first form protonated alcohol. And here we'll see reaction with hydrogen halides, phosphorus trihalides, phenol chlorides, dehydration, oxidation. So let's start the first reaction where OH bond is cleaved, right? And here we are talking about the reaction with metals. So here, as we've discussed, my alcohol acts as nucleophile. Correct. So here the alcohol reacts with active metals, and this can be sodium, potassium, aluminium, and this gives you alkoxide and hydrogen gas also. The reaction is pretty simple. You have ROH, here this bond breaks, it reacts with sodium, you get RONA and hydrogen gas. This is my sodium alkoxide. Correct. So you can react the same thing with aluminum also. You get alkoxide. And this shows that alcohols are acidic in nature. Right? This shows that they are acidic in nature. In fact, they are Bronsted acid. They donate pair of electrons to stronger base. So let's understand the acidity of alcohol. See, alcohol is actually amphoteric. This is we have seen. Right? It is both acid and base, weak acid and weak base. Weak acid, if you see, I can take one example of weak acid. So if I have this guy ROH and it reacts with, let's suppose, Br minus, it gives H plus, so it becomes RO minus and HBr. Sorry, yeah. This, if you see, is the example of weak acid because it is giving H plus. Correct. Let's take example of weak base. So I have my alcohol. It reacts with strong acid, for example HX. It's give me ROHH plus and X minus. So if you see here, ROH is accepting H plus. So it's a weak base. So it's weak acid and weak base actually. Now if I want to compare the acidity of alcohol between three alcohols, primary, secondary and tertiary, the first thing we should know is this ROH, why it is acid. So if you see water also, oxygen gets slightly negative charge and these get slightly positive charge. Why? Because the difference in electronegativity. So here also oxygen is more electronegative than hydrogen. It tries to pull electron from hydrogen, right? And hydrogen gets slightly positive charge. That is the reason for acidity of alcohol. That is what? Polar nature of OH bond. Same thing in water also, right? We have this polar nature. So this is the reason for acidity of alcohol. Now what happens is, see, if I have R group attached, R group tries to give electrons because of plus I effect. Plus I effect, right? Inductive effect. So now if R gives enough electron to oxygen, oxygen will be happy, more than happy, and it won't draw electrons from hydrogen. So if it won't draw electrons from hydrogen, hydrogen will not develop positive charge. Since hydrogen is developing slightly positive charge, it is easy to, H plus comes out easily, right? And that's why it is acidic. But if H is not developing positive charge, it won't be acidic, correct? So if you have some group here attached which has more I effect, which can satisfy oxygen, so that oxygen need not trouble this hydrogen to get electrons, hydrogen will not be a positive charged hydrogen. In that case, it won't be acidic, correct? See, the thing is, oxygen is God here, right? It has to be satisfied. So if there is no one to satisfy oxygen, it will trouble this hydrogen to get electrons, and hydrogen will be getting positive charge. It will become weaker, it will become poorer actually. But if somebody is there to satisfy oxygen, oxygen will not bother hydrogen, right? And it will not have positive charge. So here if you see, the R group is generally have plus I effect. So if I compare, let's suppose these compounds now, RCH2OH, RCHOH, and let's suppose I have 3R here, OH. So if you see here, this R is 3 degree, this is 2 degree, and this is 1 degree. So this R can supply more and more electrons to this oxygen because of plus I effect. This R can supply a little less, and this can supply a little less. So this oxygen is more happy, very, very happy. Since this oxygen is very happy, there will be very less charge developed here, let's suppose. Little bit more charge developed here. Here it will be all the more charge. Why? Because this oxygen is not much happy with this alkyl group, right? So thus we can say that the tertiary alkyl group, tertiary alcohol, in tertiary alcohol the oxygen is totally satisfied or very satisfied with the electrons, and thus it will not trouble this hydrogen much, and the hydrogen will have less positive charge, right? So it will be less acidic, correct? It will be less acidic. And in this case, since the oxygen is not very much satisfied, it will trouble this hydrogen, suck or take electron from the hydrogen, and then trouble the hydrogen, and then you see hydrogen will get positive charge and it will be more acidic. So hope you understand why this is less acidic tertiary alcohol and primary alcohol is more acidic. But alcohols are generally a very, very weak acid. They are even weaker than water. Weaker acid than water. Overall, but yeah. In fact, phenols are stronger than water. Stronger phenols Yeah, they are stronger acids than water. We'll discuss about it in phenol, but just understand that in case of alcohol, they are weaker acids than water. That is one point. And in different kind of alcohols, if you want to compare the acidic character, you have to see that the tertiary alcohol is all the more less acidic. And the reason I told you is because of the plus I effect by alkyl. Correct. So let's see the esterification process now. So let's see the esterification process is a reversible process in the presence of H plus. So here what we see is alcohol. It reacts with carboxylic acid or acid chloride or acid anhydride. And it gives ester. RCOOR. Correct. Let's see the reactions here. I have my alcohol. It reacts with carboxylic acid. So let me assume it's R-COH. What happens is here also you see this OH bond will break, and here this guy will break. HOH water will come out, and what you'll get is R-COOR. One reaction. The second reaction will be again I have ROH. I'll take acid chloride here, or I'll take acid chloride. These are all reversible reactions. So I'll put like this H plus. So here what happens is this bond breaks, and here this bond breaks. This bond breaks. So you get R-COOOR. One more reaction we have is using acid anhydride. So I have ROH, then I have R-COO, yeah, R-. Again with H plus, it will give you R-CO. This one will break, and you get R here, and plus this part which you have, right, you'll get R-COOH. This will break in this fashion. So let's see the reaction mechanism of these examples now. So in this case, to note is here sometimes since it is giving HCl output, right, we use pyridine. Why? Because the moment is a pyridine is a base. If you use this base will consume this HCl and the reaction will move in the forward direction. That is something to be noted. So let me draw a mechanism now. So let me see this reaction R1COH. The first reaction I will take plus ROH. Let me give it R2 in the presence of H plus, and as I told, this bond has to break. Correct. So first what will happen is this guy is electronegative. It will go in this direction, slightly negative, slightly positive. And now what will happen is this has lone pair of electrons. So this will attack this carbon with a positive charge, and this H plus will attack this. In fact, this will attack this H plus because it has electrons. Electrons will move from here to here. Correct. So with this what you get is R1COH, and here you get O, right? You get R2 lone pair H, right? Since electron move from this oxygen to this, it gets negative a positive charge, it gets negative charge. This positive negative combines, neutralize, so oxygen will get a positive charge here. Here also this oxygen gets negative charge, and this hydrogen is positive. Positive negative combined, you got OH, and this OH was there. So this is the product you will get. Now my H has to be removed, right? It has to be removed. So what can be done? So this H can easily come out, and this H plus will attack these guys. So with this, what you get is, let me draw here, R1C. Here you will get OH plus, right? Because hydrogen, this hydrogen came here, and with this will get a positive charge, OH, and you get O R2. Correct? Now this H2O will also be removed. They remove easily. It's a good living group. So you remove this H2O, this bond breaks in this direction, So carbon will get a positive charge now here. Right? Carbon gets a positive charge here, OH, R1, O, R2. This is what you get in carbon with a positive charge. Now we have to get rid of this positive charge. What will happen is, if you see this now, this is H here. So if this bond breaks and H plus comes out, you get a negative charge here, right? And this negative and positive will form a bond. So here, if you see, what happens is, this bond breaks, right? And the electrons move in this direction. So what you get is R1, COO, R2. And this is my ester. Hope you understood the reaction mechanism, what we did here. Actually, there are so many ways to explain this. Some people say that OH in this 2, one H2 will go and it will become a double bond. And from here also, they'll remove one H plus. There is also one explanation, right? Because in one carbon we have 2H, OH will remove minus H2 directly. You get RCO, double bond. And then in this, anyway, since oxygen has one positive charge, that's very, very unstable, it has to get rid of this positive charge, so it will give H plus out directly. So, I mean, see, the way the thing is, when you have alcohol and carboxylic acid, when you react, you get ester. This is a fact. Now, to explain these, there are so many theory. This is one theory, correct? This mechanism is a theory to explain the fact. So here, this is the fact that this happened. You have RCOH and ROH, and it reacts. You get this, right? And you get the ester finally. We'll see this Grignard reaction, reaction with alcohol. So let's suppose I have ROH. As I told, this bond will break. So I'll just put this mark here, and I have some Grignard reagent here. The moment you add, this becomes R-H MgXOR. This is the reaction. It's a very easy reaction. This is what happens. For example, I have CH3OH, you react with C2H5, MgBr, slightly negative, slightly positive, right? And this will form sorry, mistake on my part. It's OH bond breaks, right? Not CO bond. ROH. This bond breaks, right? This is what we have seen. So now if you see here, what happens is this negative and hydrogen develops slightly positive charge. This is slightly negative, right? We have seen this due to polar nature. So this will come and attack this. This will attack that. So what you get is C2H6 and MgBr. Here you get OCH3. Correct? This is the typical reaction mechanism. Let's see the acetylation reaction. I think we have seen similar kind of reaction. You have alcohol. It reacts with acyl halide or anhydride. You give some heat, right? And it forms ester. So we'll see that this process called acetylation. Why? Because this is the process of introducing acetyl functional group. example, I have ROH, and you have, I've seen this reaction actually, COCl. Right? When you react, you get RO, CuR dash plus HCl. This is a typical reaction. Or anhydride. In fact, this also I have shown you. R dash COO. It was R dash. It gives this one. Correct. So here also, if you see in both, all this OH bond is breaking. We'll see one reaction mechanism if you want. So let's see CH3 COH reacts with CH3 CH2 OH. This is negative, it will get negative charge, it will get positive charge. Right? Since it got positive charge, this oxygen here will get attracted towards it. Bond, slightly negative charge. Here I have H plus, so it will get attracted to H plus. So with this, let's see the product. You get CH3C. This becomes OH. There's also OH here, and here you can have CH3 CH2 O. This is the bond here actually. O H. And since oxygen is giving, it gets a positive charge. So positive charge on oxygen, not that good. So hydrogen will break its bond and it will go off. So you get CH3C OH OH O C2H5. Correct? H plus went off. Now this is pretty easy, right? I can say that directly. There's two OH in particular carbon, so you can say minus H2O directly. So it becomes CH3 C double O O C2H5, right? And you get this output, right? That is one way. Or if you want, what you can do is H plus what you have got, you react here, right? It becomes H2O plus, it comes out with the plus sign, it comes out with the plus sign, this bond breaks and H goes out. Same thing what we have done in the past, I think 2-3 slides back. You can do that way, or you can just say H2O goes out. Both are almost same. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.